Hi guys, hello and welcome to another tutorial. And in this tutorial, we're going to be exploring concept of multi-sig wallets. This video, we're going to create a multi-sig wallet contract. We're going to test it. We're going to deploy it, and we're going to interact with it. And we're deploying it on the Rootstock network. But before we start exploring this interesting subject, let me talk a bit about Rootstock. So now, what is Rootstock? Rootstock is a layer 2 EVM compatible blockchain, which is built on the Bitcoin security layer. The Rootstock's native currency is the RBTC, which is pegged to the Bitcoin. Like every other EVM compatible chain, you can deploy your Solidity contract on Rootstock. And since it's a layer 2 also, it has low gas fees, it has fast block finality, and since its native currency is pegged to Bitcoin, there's less fluctuation in the gas price. Now, the Rootstock network is built on the Bitcoin layer. This means that whatever you're building, whatever project you're coming to build on the Rootstock chain has that security layer. Whether you're building your DeFi apps or your staking pools and whatnot, it is going to sit on that security layer, which the Rootstock network is built upon. Besides the technicalities, technical benefits, Rootstock offers lots of opportunities for builders. We have the Rootstock Hacktivator. Here on the Activator, you can submit ideas. You earn uh, for submitting ideas. You also earn for claiming ideas and working on them, sort of like creating that open source native ceiling where, either you're a contributor or you're a contributor just by submitting ideas and you have a cool idea, you can submit it. Or, you see an idea that has been submitted and approved and you work on it, which is really cool. I've been a contributor to the Rootstock Activator for months now, and it's been a really interesting ride, contributing to the Rootstock ecosystem, from the blogs, the articles, documentation, the videos, and, many different expressions that the Rootstock has given me. Besides the Rootstock Activator, there's the Rootstock Collective. Say you are, have funds to stake, you can stake on Rootstock Collective and get interest for your investments, or you're a builder and you're seeking liquidity, you're seeking investment, you can come to Rootstock Collective and then get funded. Aside this, there is also a well-engaged community, the Rootstock Discord server that you can join, to keep up with updates, keep up with all the interesting things that happen in the Rootstock ecosystem, guys. Join Rootstock today, guys, and you get to benefit from all the plethora of opportunities that are present on the Rootstock network. And with that said, let's go to subject of today, Multi-Sig Wallet. Like, the normal wallet, like, let's say you open an account on your MetaMask or your Rabi wallet or your other wallets, which when you create, you are basically the sole proprietor. So your private key, you own it and you use it to sign messages, sign transactions, and every other thing. Multi-sig, on the other hand, the multi-sig wallet, which an example is like Safe, the most popular example. As the name implies, multi-signature wallets requires multi-signatures for things to happen. So say for a transaction to be executed, it requires multiple signatures for for anything to happen, basically transactions being executed requires multiple signatures. And now from this diagram, we can say, for example, we have three owners. Multi-sig wallet is created, addresses or owners attached. And there's something called the quorum. The quorum is the minimum number of signatures required for a transaction to be executed. Is the minimum. So in this our example, we have three owners. The quorum is 2. That means at least 2 people must sign a transaction for it to be executed. Now, that is that about the theoretical explanation. Let's go ahead and build a multi-sig contract. Now, the prerequisite for this video is that you have an understanding of writing smart contracts in Hardhat. And you're not just a newbie. So if you're a newbie and this is your first time, writing smart contract, I'll advise that you go to the Rootstock, devs to devs, sorry, let me check that. Okay, so there is a YouTube channel dedicated. So from devs to devs. Yep, so this is the YouTube channel. So I advise that you go there, you go straight to this channel and you'll check out different beginner videos. This is also a beginner friendly video, but like you need to have a few fundamentals of how to deploy, how to write tests and all of that. So the specific aim of this video is to focus on the multi-sig wallet itself. All right, with that said, let's now go straight to it. I already have a Hardhat project scaffolded and my Hardhat config. This is the Rootstock network. And then I have the RPC already gotten. Then I attached two accounts for the purpose of signing transactions when I'm interacting with the smart contract later on. So with this, let's go to the smart contract. Now, these are smart contracts. Yeah. We start with the license identifier. Then we define the Solidity version, that 0.8.24. So now define our smart contract, we name Multisig, and then we define a few events. Now these events, deposit, submit transaction, confirm transaction, execute transaction, and revoke transaction. These are events that will be emitted at different points and in different functions in our smart contract. So deposit will be emitted when RBTC is deposited into the smart contract. Submit transaction will be emitted, and we can see they are indexed. So when you indexing is simply used to help subgraphs index specifically. So by indexing on the sender, that means when we're using a subgraph to traverse through this smart contract smart contract data, we can index those data based on the sender's address. So that's simply how indexing works. How indexing works in databases. So we have a submit transaction, and then this will be emitted when the transaction is submitted. We have confirm transaction emitted when a transaction is confirmed. Same goes for execute transaction and revoke transaction events. Now we have three state variables to start with. We have an array of addresses called owners. So these will be basically passed in when the contract is being created. So we need to define all the owners of the contract. Then we have a mapping which maps address to bool, and it's called its owner. So this would define all the owners, because we want to prevent duplicate owners where a person can be passed in 3 times. So if all we had was the array, a person could be passed in 3 times, and then let's say we have 5 owners and the quorum is 3. If one person appears 3 times, that means that person can confirm a transaction 3 times, which meets the quorum, and then that is a security vulnerability, as you can see. Then we also have the quorum here, which is the minimum amount of signatures that must be gotten to execute a transaction. So now we have our transaction struct, which contains address, value, data. Now the data in that says if the transaction now that is to be approved and executed, if the transaction has to do with interacting with another smart contract. Now that interaction would need to be API encoded and then passed in as bytes into this multisig. Then we have the value. Value is the amount of RBTC that's being transferred, the amount that's being transferred. Then executed, this is basically stating that this transaction has either been executed or not. Number of confirmation keeps track of the number of number of owners in this case that have approved the transaction. Now we also have two more state variables. We have transactions array, which keeps track of all the transactions. And then we have a nested map or a 2D map, which maps the transaction index to the address and then to Boolean. So this basically maps transaction index to owner's address to Boolean. It basically helps us check if a particular person, a particular owner, has approved a transaction. Now we have some helper functions. The only owner function helps ensure that only a owner, that means this owner that we have here, the owner's list, yep, the person who is not part of, the person who is not an owner cannot access a function. Then TX exists. This helps us check the validity of a transaction. And here we're saying TX index is less than transactions length. And that's because we are not using a dedicated ID. We're simply saying, okay, the transaction length starts from 0, right? And if a transaction is created, the length updates to 1. So we're now saying, okay, the index of a transaction is simply transaction length minus 1. So if a transaction is submitted, the transaction array updates to 1. That means the ID or the index here will be transaction length minus 1. That's what we're using here. So if the transaction index is in any way greater or equals the transaction length, then we know that's an invalid transaction. And we're also checking if the transaction has been executed. Yeah. And checking if a person, if an owner has confirmed, that means has approved a particular transaction or not, which is also the case here. So now we start here with the constructor, and the constructor receives an array of addresses and the column. Firstly, we check that the array of addresses, which we call the owners, is not empty. Then we also check that the column is greater than 0 and that the column is less than the number of owners passed in, because if you have 3 owners and you have 4 as the column, and the column will never be reached, because no matter how many signers sign, it will never get to 4. So that means we need to ensure that the column is less than or equal to the number of owners. Now we do a for loop here, and in this for loop, the for loop is looping through the addresses that were passed in as owners. We're checking if we have 0 address, if the owner existed here. This is where the duplicate thing is checked to ensure that a person is not made an owner more than once. And if all these cases, if all these checks pass, we're going to register the person as an owner, and then we're going to push into the owners array. Then we set the column here. Now that the constructor is all said and done, we are going to do this. We have a receive function, and this receive function simply makes our wallets or our contract able to receive native token, which is RBTC in this case. And then we emit our first event. Now, the next thing we're going to do is create a submit transaction. Now, the submit transaction receives to address the value and data as inputs or as parameters. Then what we do first is we check if the person calling the transaction is an owner. Then we require that the to address is not a 0 address. And after doing that, we create a transaction object from the transaction struct. Then we push that created object into the transactions array. And then we emit the submit transaction event. Now the next thing is the confirm transaction. Now this is basically the function that a particular owner would have to call to approve a transaction. Now at this point, we expect that the transaction has been created. The transaction has been created and has an index. Now we call it the only owner function. Then we check if the transaction exists. We also check if the transaction has been executed, because if a transaction has been executed, we don't start adding approvals on an already executed transaction. And we also check if it has been confirmed already, so to prevent double confirmation. Now, if all those checks pass, then we want to update the confirmations to true. Then we want to increase the number of confirmations by 1. Then we emit the confirmations, the confirmed confirmation. Up next is the execute transaction. So now in the execute transaction also receives the TS index, and what it does is basically it executes the transaction. We check if it's an owner that is calling this function. We check that, okay, the function exists. We also check that it has not been executed because we don't want to have double execution of a particular transaction. Now we take that transaction by its ID, we index into the transactions array, then we get that transaction in memory, and then we move it to storage, which is what we're doing here. We move it to storage. And then this is where the whole gist is. We are checking that the number of confirmation of a particular transaction has reached the quorum. That means it is greater than or equal to the quorum. If it is not up to the quorum, then this exact check here is going to cause a revert in the transaction execution. If all these cases pass, then we're going to use the check effects interacts CEI rule to prevent reentrancy. So what we do here is we update the transaction state, that's the executed property, to true, because we don't want a case where we could have actually first done this call here, would have done this call before updating this, but then that would be reentrant, because imagine that this call here is being made to a malicious smart contract, which can also re-enter this contract. So in that case, by re-entering, it's vulnerable to re-entrance attack. So that's why we have to first update here. That's why it says check effects. So now once we have updated the effect here, then we're now going to make the interaction here, which is what we're doing here. So this basically does, what we call executing the transaction itself. And so we are passing in the call data, we're passing in the value and everything that has to do with the transaction. Then we require that it succeeds. That means the transaction is successfully executed. Then we emit the execute transaction events. Now the last major function that we have here is the revoke confirmation. This is the function where someone can like revoke a confirmation. So let's say you're three, and then one person has, the quorum is two, right? One person accepted, but the other two revoke their confirmation. That means that transaction will not be executed because only one person approved, the other two did not approve, they revoked. So that's what is happening here. It's simply just updating the confirmations, mapping, and then we're updating the transactions. So here we index into the transactions array to get that particular transaction. Then we index using the property norm confirmations to get the number of confirmations. And after doing that, we decrement it by 1. All right. So with that done already, we have some basic functions that we use to read data. We have the get owners function. So this will help us. This returns all the owners. Then we also have the get transactions count. So all the transactions that has been created, this returns it. Then we have a function get transaction. So this returns the data of a particular transaction. And all you have to do is pass in the index. And then the last one is confirmed. So this checks for us if a particular owner has already approved a transaction. So guys, this is basically our smart contract. Okay, so let me check if this is okay. Beautiful. Now, before we progress, let's check if it compiles correctly. npx hardhat compile. Okay, now that was successfully done. So what we're going to do next is we're going to have our test. Okay, so I already have tests here, and yeah, forget the red squiggly lines. Basically my VS Code extensions misbehaving. So what do we have here? So we have the test cases described, and let me start from the before each. So this is like, an async await, which basically executes first before all these other test cases below come to play. We have our multi-sig contracts here, and then we can see it here. Okay, name of our, this is multi-sig So I need to edit this Multisig. So we create an object of the Multisig contract. Then we deploy it using, passing in the owner and the quorum as arguments. Then wait for deployment. So all these test cases here, we have initializes with correct owners and quorum. So that's what we do here. We check if the owners were initialized correctly, as the owners that were passed in. And then we also check if the contract transaction count is correct. Then next year, we check if it allows an owner to submit a transaction. Yeah, so we do a dot submit transaction here, then try to check the transaction details here to see if it was correctly done. Another thing we do is to prevent non-owners from submitting transactions. So remember in the contract we have this only owner function. So that is basically ensuring that only owners that were passed into the constructor of the contract, only them can access those particular functions. Then allows multiple owners to confirm transactions. So this is where like, okay, they're approving the transaction to increment the number of confirmation so it can get to the quorum. That's what we're doing here. We're connecting different signers. So at this point here, we first create the transaction. Here we sign. So the first signer signs here, the second signer signs. So we now get the number of confirmation, which should be 2. Then prevents duplicate confirmation. So here it prevents a person from approving twice. Yeah, prevents a person from approving twice. Then for this executes transaction only after quorum is reached. So when we're interacting with our smart contract, we're also going to check this because this is majorly the purpose of the multi-sig to ensure that until the quorum is reached, nothing is executed. So we can say that after the confirmation, we are expecting that it should revert with this not enough of confirmations. Okay, but let me check not enough confirmations. Let me check if this matches correctly. Okay, this should be quorum not reached. That should be the error message. Yeah, quorum not reached. All right, so we have prevents execution of already executed transaction. So if a transaction has been executed already, as you can see here, we have 2 owners have confirmed, and then the transaction has been executed here already. So we should expect this to revert. Then we also have, like, it's a very elaborate test. So this also checks to allow an owner revoke confirmation before execution, and also prevent revoking if not confirmed. So for a person to revoke, he must have confirmed already. So that means that is what this is basically checking. So let's run our tests to see. npx hardhat run tests. Sorry, not run tests. And the name of our test is multisig. Okay, so we have 4 failing tests. So we have prevent non. Okay, let's see this. Not owner or reverted with not an owner. All right. So let's fix our test cases. Not owner. So let's make this not an owner. Okay. The second test says expected transaction to be reverted with already confirmed or reverted with already confirmed. Okay. All right. So already executed or reverted with already executed with a okay. Alright, so these are just like basic reverts messages, not tallying. Assertion error event revoke confirmation does not exist in contract. Okay, let's check that out. Okay, so this exists here. But then why? Okay, let's run the test again. Okay, so we have just one error failing now. We're gonna fix that too. Okay. Okay, 2 tests basically. So it says not an owner. So we have not an let's quickly get that. And then the last error says event revoke confirmation does not exist. Does not exist in a contract. So let me see. Revoke confirmation. Let me see the contract. Revoke transaction. Okay, this should be revoke confirmation. Should be revoke confirmation. So means I'll have to update this here. Revoke confirmation. So we have to compile. It's Hardhat. Compile. So when you're like testing your contract, you get to like update some stuff, mistakes and all of that. So let's run our test again. Good. So everything passes. All our test cases pass. Beautiful. So now, since our test cases pass, we can go straight to deployment. And since we're using Hardhat, we can go straight to the ignition folder, create a file in modules. And I already have one here created, Multi-Sig.ts. So what we're basically doing here is we're following the pattern that was, stipulated by Hardhat's ignition rules. So we have the module created, and we're defining owners and then the quorum. So we have three owners, three addresses here that will be owners. And we have our quorum should be 2. That means we expect only 2, a minimum of 2 of those addresses to sign or approve any transaction for it to be executed. So now we are passing them here as arguments, and then this is being returned. So let's deploy the smart contract. Let's deploy the smart contract. So that should be npx hardhat ignition, deploy ignition, modules, multisig, rootstock. So we're going to give a deployment ID because we want our verification to be seamless. Deployment, let's put it THE, the multi-sig deployment. So all we just have to do is wait a couple of seconds, depending on how fast the internet connection is. It should be like very fast. Okay, says and then okay, connection timeout. So that's my internet connection right there. Okay, so we wait for it to, deploy this smart contract on the Rootstock Testnet. Now, for this to run successfully, you need test RBTC, and you can get that in the Rootstock faucet, which is this Rootstock RBTC faucet. You can get tests faucet from here, and ensure you do have them before you try to deploy the smart contracts. So we're waiting. So depending on the speed and strength of your internet connection, this should be very fast because failed, and we should try that again because I'm having internet connection issues right here. Right, so this is going again. Okay guys, I hope this works. I'll just wait a couple of seconds more, and so after this, once this deploys correctly, verifying it should be very seamless. Verifying it should be very seamless because we're creating it under a deployment ID. So okay, beautiful. So this work. So we have our contract deployed at this address, then we can quickly verify it. npx hardhat verify. Let me just do the multi-sig deployment. All right, so you should give us an address. Okay, I think I missed a command, probably ignition. npx hardhat ignition. So that should be the missing command. Yeah, and it's verifying now. So she give us a link, and we're able to see our code has been deployed already. Okay, this failed. npx hardhat ignition verify. Okay, let me try this again. All right, so this worked. So let's copy the code, copy the link rather, copy the link, paste it in, and we'll be able to see our code right there on the Rootstock testnet. Boom, so we got it. So it's loading the code, and yeah, this is it here. And if we check the transaction tab, we'll see the contract creation transaction right there, right here. All right. So now that we're deployed, let's go straight into interacting with the smart contract. That's we're interacting with the Multi-Sig Wallet. And what we want to do is we want to try to create a flow, a sequence of actions, right? So from what I said here, we have 3 owners on a particular Multisig, which is the Multisig wallet that we have already deployed on Rootstock network. And then we have the quorum to be 2. So I want to try to use one person to create a transaction, submit it in the wallet, then use another signer to sign so that the quorum will be reached. Then we're going to execute that transaction, and that's what I will want to do now. Okay guys, so we go to the script folder, and then so we have this. There are a couple of things that I want to point out. We're using Ethers for the contract interaction. and we have the contract address. So I will need to copy and paste in the, which is this. So once we paste that in, we get the ABI. Now the ABI can simply be gotten. This is the human readable ABI. You could also use the JSON ABI. I just love using the human readable ABI because it's very intuitive. So you could paste this, your the contract into an AI and then ask it to generate the human readable ABI. Or you could like either write it yourself. But using an AI is like, so now we have two signers here, and this is because I added in my Hardhat config, which you can see here. My Hardhat config, which you can see here, this two. I added the private keys to these these two accounts that I have as owners on the multi-sig. So that is why in my scripts now I'm able to get the two of them here. Now I create a contract object which is representing the multi-sig using the ABI and then the contract address. Then the first thing I do is I get the owners. So I'm trying to create a flow, a visual flow. So when I run the interaction script, everything is just going to be like very, very intuitive. Now, this part, I'm ensuring that the owners of the multi-sig contract includes the address or the account I'm using to sign this transaction. And the first step here is I'm submitting a transaction. So I create a to address. The value is 0. Then data is 0 also because I don't want to send anything. So I submit the transaction, then I log the hash, then I await. So this await tx submit await is basically a method that pauses and ensures that that transaction is completed on the Rootstock network. So it doesn't just continue and then leaves it. So it ensures that that transaction is executed first before it moves on. We get the transaction count, right? Because we know that, okay, if this transaction has been submitted successfully, then we should be able to get an updated transaction count. Now, the next step is to confirm. So using that same signer, we approve the transaction using the confirm transaction and we're passing in the index. Now, we check the status of the transaction because after approving the transaction, we expect that the number of confirmations on that transaction should have increased by 1. So the next thing we now do is we introduce a second signer, which is different from the first signer that we're using, the person who submitted the transaction. So we connect that signer to the multi-sig contract, and then we also approve or sign or confirm that transaction. That means the number of confirmations on that account should have increased to 2, right? So now we wait for the transaction to be mined or executed successfully. Then we move on to check the transaction status again, and then we execute the transaction in this try patch block. So I'm going to run the scripts now, and we're going to let's follow through what's happening here. So we do npx hardhat run script multisig, multisig.ts, and the network is rootstock. Okay, so this should take a bit because we're following each of the sequence. So we have our signers. Now these signers are the ones that were in my .env. So these are the two signers. But if you notice, this address matches this address. This address matches this address. So those are the two signers I have that are owners also. Owners of the Multi-Sig wallets, which I'm going to definitely use to approve transactions. Now submitting a transaction, which is the first thing I did here in the script. So here I've submitted a transaction and then it logged the hash, right? So now after logging the hash, you see we waited. So for it to move to the next step, that means the transaction has been successfully mined already. So now we can see it gets the transaction index and we can see the new transaction index is 0 because we already have a transaction submitted. So the transactions array length is 1 and then the index would now be the transaction length minus 1, which is why we have 0. So now the next thing is confirming transaction, which is what we did here. And then as you can see, it has logged the hash of that confirmed transaction thingy. And now I think we have a wait there too. So this is basically waiting for the confirmation transaction to be executed, right? So once that is done, we should see it move again. Good. So it has been completed already. So it has moved to checking the transaction status. So we can see that number of confirmation is 1. So since the first signer created, submitted the transaction and then approved it, so the confirmation is 1. Now we connected the second signer, and the second signer is also currently approving. So the approval or the confirmation transaction has been submitted already. So now we are waiting. This is where we are. We're waiting. So once that is done, we should see that the confirmations on that transaction should increase. We should also see that. So within a few seconds, we're waiting on that transaction to be mined. Yeah, so we're just waiting a couple of seconds. So basically what we're trying to simulate is simulate how multisigs work. We have deployed it, we have tested it and everything. But I want to see exactly, using the script, how it feels like. And once we're done with this, I'm going to show another way. We're going to test to see if the quorum is not reached, what happens. Okay, so beautiful. So that has been confirmed already, and we can see now that the confirmation is 2. So basically, the confirmation has been reached, guys. Now, since the confirmation has been reached, what will happen next is that this execution should work perfectly. So now we're waiting on the execution transaction has been submitted. Now we're waiting for it to be executed. And once it is executed, we're done with this sequence. And then we can see exactly how Multi-Sig Wallet goes. So this is a very useful case for where, hackathon payouts, we can see transaction executed successfully. So in case where you don't want one of the hackathon people disbursing funds to be, fraudulent, you can use a multi-sig or a company disbursement fund. You don't want to give power ultimately to one person, you can use a multi-sig. Or it could just be like a family thing where there is a payout or a family will. So the use cases of multi-sigs are very, 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 and there's a plethora of them. So guys, now with that said and done, let's try to comment this out. Let's try a scenario where the quorum is now reached, and then let's see what will happen. So everything is going to go, everything above this commented code would work, but everything below would fail. But before we do that, let's check to see. Yep. So you can see that the block Rootstock Explorer has caught all of the executions. So we can see the submit transaction by the first signer, the confirm transaction by the first signer, the confirm transaction by the second signer. So when we switched signer, we can see that also the signer switched here, and then the execute transaction by the first signer. So we can see all of that. So it's very cool stuff here. It was all caught by the Rootstock Explorer. Now let's try and run this and let's see what happens. Okay, so we have the two signers. It follows the same sequence as the other one. It's just that we're expecting it to fail. Okay, this is a timeout, so we have to run this again. Another timeout. I hope my internet forgives me. Okay, good. So we're good to go. We're good to go. So we're submitting a transaction. So we use the first signer here to submit this transaction. And once it is mined, the next step is the index. So we're waiting. So that was done already. It got the index. So the index is 1 because the first transaction that we had, the index was 0. So now the index of this transaction is 1. And then confirmation. So it has moved to the confirmation stage where the signer is confirming, submit a transaction to confirm that, to confirm. So this is these are the details of the transaction. So it could literally mean, you could actually paste in a valid call data, and this works perfectly. All right, so we're waiting on, the confirmation transaction to be executed. And then I think once that is executed, this doesn't, since it's out of the way, the execute transaction should fail. So just wait a couple of seconds. Okay, good. So that has gone through. So we're here. So it went through. The confirmation was 1. the confirmation was 1, and then we can see it failed. Quorum likely not reached yet. So we can see that since we did not bring in a second signer to approve the transaction so that the quorum be reached, the execute transaction failed, which is basically the main essence of a multi-sig smart contract. So guys, we've successfully seen what happens. So we can see from the Explorer, submit transaction is there, confirm transaction is there. But then since the execute did not work, it's reverted. So it's not among the transactions here. So we've been able to build a multi-sig wallet. We tested it, we deployed, and then we also interacted with it. Played around with it to see how it works. And also the use cases, possible errors that come up when you're building something like this. Also security vulnerabilities, where we talked about preventing reentrancy, talked about preventing duplicates, duplicate signers. I know so many interesting things that we talked about. So guys, that's it for this tutorial. It's been a jolly ride, bringing you guys through this very interesting topic. Looking forward to, seeing what you build on Rootstock, guys, harness the opportunities, the technical infrastructure that Rootstock offers, the benefits, and the very vibrant and growing community of the Rootstock ecosystem. Until next time, guys.